to provide support for the underlying technology of the data space. And so you can basically use OwnCloud to connect to the data space as well. And then we're working on adding search with NIF, the Neuroscience Information Framework. They already search many different data repositories, but then they're working on integrating it so you can search the data space. And then the next, a little bit longer term, is adding the ability to support doing analysis where the data sits. Right? So this is the next phase where instead of copying the data somewhere to do your analysis, particularly things like brain images, you don't want to copy that. What you really would like to do is, if somebody is willing to provide the computational resource near the data, so ideally at the same data center where the data is sitting, you can put in a computer that can serve and run a particular analysis pipeline. And then all you move is the extracted features, which takes nothing to move. So it's much lower bandwidth. And then you also support semantic tagging and search. I'll explain some of that. Community ratings, collaborative analytics. These are future directions. So OwnCloud I mentioned. And in the latest version, 5.0.10, they've added support then for the IRODS and INCF data space. And then we're using this, as I mentioned before, we're building this global data federation, but we were able to have it up and running in a very short amount of time, essentially because Amazon has already put in data centers all around the world. So we could use servers in Seattle, servers on the East Coast, I think they're in Georgia maybe, and then in the EU, I think they're in Ireland, and then also in Asia Pacific, which is in Singapore. And so that basically 4 zones around the world all have low latency access to the metadata so that you can navigate and browse those repositories rapidly anywhere in the world. So the next layer, once you've got data in the data space, the next thing that we're doing is building off of that NeuroLex website that I've been telling you about, which is this website. It was developed between INCF and NIF, the Neuroscience Information Framework in San Diego. And this is the place where all those ontologies, the standardized vocabularies and classifications of brain structures and diseases and molecules are all being kept. And so as I was saying, this is in a wiki, but it's a semantic wiki. So this means anybody can come in and add terms if they need to. If something isn't defined, the community can define it, or if something needs to be better defined, it's all editable. And the purpose here is that this is the space that will be promoted. It's not the INCF knowledge space, it's the knowledge space. And this is a collaboration with many different groups, with NIF, but it will also include, Gordon Shepard's group. It will include the Human Brain Project. It will include One Mind for Research. There are other efforts all around the world that I've been talking to that are basically planning to adopt this as the single space for maintaining all definitions of all vocabulary for everything that they need to annotate. So all metadata would be defined here. And then in order to motivate people and to keep this really as a rich knowledge source, we're going to be promoting this as a place to maintain living review articles. So this is where you can go and actually publish your data set, so with a link to the data is sitting in the data space, and summarize the sets of data for, say, for example, if you're interested in the thalamus, you can basically help maintain an article that tells the current state of knowledge about the thalamus while pointing to data that supports that summary, so that you can point to, well, here's a data set that describes the morphologies of the neurons in the thalamus, here's a data sets that describe the function of the thalamus, the connectivity of the thalamus, and so on, can all be linked to through there. But also, not just data, but models and literature. And this is, so the point is that this takes the kind of the Wikipedia idea, but it uses a semantic framework. So it's a semantic wiki. And behind that then, for any of you who are familiar with semantic web technologies, is an RDF store and a Sparkle endpoint, right? So that this then is all queryable through Sparkle. And that means then you can find the data that you're looking for. You can find the related data. You can find the protocols. You can find the labs. You can basically find all of the related aspects in one global source. So this is, it's being built now. It's being populated with existing ontologies from the NeuralX. And then a number of groups are working on importing specific data sets. So for example, on ion channels, on neuron types, on brain circuits, on brain areas, global connectivity. There's a range of sort of starting point data that are being assembled and built and brought into this version. So when this launches, this will have a good starting point populated with examples of the data. In addition to this, it's something I haven't built a slide around, but there's something called the lab space. And it's basically for any individual lab that is producing data, gives them the same framework, the same software, the same framework, but just for a private instance, so that it can be useful within a lab just to curate and get organized your own data. You can still go to the global knowledge base to look up the terms, the standard terms to link to, but you can organize all your data locally. And then when you're ready, you can hit a push a button and push this out to the global knowledge space as essentially a type of a publication out to the knowledge space. So it gives a way, because we know that many times people, they want to take some time to clean up and organize their data and get it properly annotated before it comes public. And then that gives them a space to do that. And if you're interested in lab space, we can talk to you about that. But in addition, one of the things that we'll be working on in the knowledge space, kind of related to the lab space, is a way of actually, once you've curated your data set, say you've gone through and you said, here's a patient cohort with these properties, they've got this volumetric size of this brain area, and they've got these symptoms, and they've got this particular behavior, so forth. You can prepare all of that, curate all of that, point to the data, and then submit it as a data publication, actually. So we're working with publishers that you could actually just submit directly from the knowledge space to get a published article that, again, would also have the electronic form and point to the original data, but then you would get your PubMed ID and you would get your citation ability. So the semantic search and notifications then, of course, part of what that whole framework provides is that you can sign up and you can say, notify me anytime some new data shows up about my favorite brain structure, about my favorite neuron, about my favorite disease, so that you get notified. If there's new literature too, right? So this will become a way where you can stay very actively aware of new data, new models, new literature appearing, and then be able to go in and do related searches, and it gives you really a tool then for finding these things. Then the brain, so how is the time actually?
10:30, maybe we can stop for tea.
Good, so I'll that's good, I've taken longer than I thought, but good. The one last piece is that these collections of data, we really see these as being the next generation brain atlases. If your data is curated and annotated to the common vocabularies, and they're registered or they're registered to a common coordinate space, these then become searchable data sets within a brain atlas. And so this becomes a way then of really looking at the organization of the brain through the data and searching it through the data, and also finding links and relationships between species. And ultimately, where we're headed with this is that by integrating data from basic sciences along with animal models of diseases, along with clinical data, you'll really be able to, using that semantic layer, so you're using the same vocabulary across those layers of data. This should accelerate our ability to understand the translatable elements of disease across, from basic to clinical using animal models. So I'll stop there. It's time for tea. Before we do that, if there are any questions, I would be glad to take them.
Yeah. Is it possible to limit the viewing data? Who can share data to control that?
Right. So in the data space, yes, absolutely. That's part of it. You set, I only want this to be private to me, or I only want this other group to see it, or it's public. So you can completely control that. And then the links in the knowledge space point to the data space, so they go through that same permissions model. However, we are taking the stance that if you're putting content in the knowledge space, all the content in the knowledge space will be visible. If you want to keep something private for the knowledge space, you do it in your own lab space. And that's the model we're using.
You have the core database and the ontological data dictionary, then you form a semantic search. You use the word called sparkle there. Is it for create a, what do you call it? It's a search or what is that?
Sparkle is an insider's term. So it's an API and it's a way of doing queries to these semantic stores, to these triple stores. It's just for those who are familiar with it. Other questions?
Seems most of your focus has been on neuroimaging. How about those on the electrophysical signals?
He's an EEG guy.
Okay, good. So yeah, I had to choose one to focus a little bit more detail on. I didn't get into the EPHIS, but we have this whole task force on EPHIS, and what they're doing is a mixture of things. Finding the standardized metadata. So there's an object model for electrophysiology data that they're working with. They're working on a data format with HDF5, if you're familiar with that. And then they're testing it for a whole range of different types of EPHIS data, from single cell to extracellular to multi-channel EEG. Yeah, so it's definitely an active interest within our groups.
Just to give you an idea, just raise your hands. Anybody here working on EEG or similar to EEG? Just so that.
Okay, yeah, this is helpful.
How many people are around?
I should have talked more about
okay.
that.
Then next, MRI, fMRI. Just raise up your hand.
Oh, okay. So
you
my
can see the,
yeah. My bias. Sorry, guys. I should have focused more on this.
But fMRI EEG fusion.
Ah, yeah. Who's that? Hey, great.
That's
Excellent.
coming.
Excellent.
That's coming.
Very good.
Yeah.
Very good.
So anyway, we'll break for tea.
Great.
There will be a group photo outside there somewhere.